horizon design profile. And they use capital letters, and in order from top to bottom, you can remember this, are A, E, B, C, and then R. Okay. Actually, sometimes there's an O.
Isn't O above A?
O is above A, but only rarely do you find an O horizon. An O horizon is a horizon that's virtually all organics. If you go into the cypress dome where there's that annual duff, all the leaves come down, that's the duff, you'll get a layer that's just vegetative debris. That would be an O horizon. Sometimes prairies are productive enough to have an O horizon. I don't believe we've ever seen, we've never called anything an O horizon from a prairie on campus. An A horizon with a capital A is a horizon that collects stuff. Collects organics mostly, organics that get mixed in. Any material that collects at the surface gets incorporated into the A horizon. Okay? Below that, the E horizon with a capital E. E stands for, and we'll do this on Monday, E stands for eluviation as opposed to illuviation. Eluviation are processes that take material out of the soil and either move them somewhere else or move them down further into the profile. Okay? So the E horizon, if it's there, is missing stuff. Okay? The stuff that was once there, that's still in the A horizon, has been transferred downward usually. Okay? The B horizon, capital B, which is underneath, is the illuviated with an I, I-L-L, viated. Illuviation is the receipt of all the eluviated material. So they couldn't have made the language any more confusing. So the B horizon usually has lots of crap that got washed out as the water table dropped out of the E and collected in the B, and there it resided. Okay. Below that is almost inevitably a C horizon. A C horizon is boring and inert and usually is just composed of physical sediments, detrital sediments, broken up bits of mineral and rock. Here in Florida, it means just quartz, clean quartz, white sand. Okay, and then below the C horizon, you'll often have an R horizon, and R stands for regolith, and regolith is just broken up bedrock. The regolith horizon is right at the top of the bedrock. So when you get close to the bedrock, you start to pick up rubble, and then the soil profile ends. Okay, this is what a profile looks like from this prairie. Taken from somewhere along in here, I don't recall which. This was part of a class project. The group decided that there were two A horizons, an A sub 1 and an A sub 2, so they both looked like A horizons, but were different and distinguishable from one another. They decided here that there was no E, but there was this, sometimes soil scientists will waver and say, this isn't a B, this isn't an A, this is a BA. It looks like a sort of a combination of a B and an A. So they did not describe an E here, a B below that, a large C below that, okay, with a C sub 1 and a C sub 2. And I believe when this score, this profile was taken, it didn't go deep enough. It went at least 3 meters down. It didn't go deep enough to hit the bedrock. Okay, so that's what this habitat looks like. And if you want to hold that. Now let me just, and the colors on there that they chose to color the profile actually reflect real color. Okay, so they're not just randomly chosen kinds of things. Okay, here's the pine upland. You can see next to that, they're different. Okay, here an A1, an A horizon was described. There's an E horizon that was described here. There's an AE transition. EB, an E, and then a C. That was taken from the heart of the pine upland. So why don't you model that one? Very well done. Very well done. And this, you can see right away in stark contrast, just based on color, is a profile taken from the cypress dome. Okay. There's a O horizon that's of appreciable thickness here. Lots of A, some E, no B, a C1 and a C2. I wonder if this is mislabeled. Well, in any case, suffice it to say, this profile is very different than this one, rather than, yeah, you've got the prairie. No? Yes, you've got the prairie. This is very different from this one. This one turns out to be not that different from this one when you start looking at the particulars. So again, there's a stark contrast between what you see there and here, and a less contrast between what you see here and there. And more interestingly, based on the study from 2 years ago, that change from, here's the prairie, we should stand in the right order. So we get on that side. That's why I'm so damn confused. There we go. We didn't rehearse this. The transition from here to here, at least under here, is relatively sharp. You know, when you take two profiles just a meter apart from one another, right on the edge, you go quickly from this to this. However, you can core a series of profiles as you move into the pine upland, and you gradually go from this to this. Okay. So again, what we're going to attempt to do is see if this is just a once in a lifetime kind of oddity, or is it replicatable somewhere else? And I always thought corkscrew would be a good place to test that. So, all right. So the purpose of today isn't to make these products, it's to get you used to the process of profiling, so when we show up at Corkscrew and lots of people are watching, we don't look like a bunch of mumbling idiots. I'm good at being a mumbling idiot. So, and it just gives you some sense as to what it's all about. So, all right? Now, there's, for each one of these descriptions, let me have the prairie. I'll pass them around. Have a quick read. There are different types of characteristics that go with each horizon. One thing we do is we prescribe a color. We actually identify a color, and to get color we use something called a Munsell color chart. It turns out that color is taken very seriously in the geological world. You ever go to Home Depot and you pick up those paint swaths? And if you ever read them, they always have like first they have a name, like, you know, macaroni and cheese yellow, right? And then underneath it are a series of numbers or codes. Did you ever see that? They have letters and numbers. Okay, those are Munsell color codes. If you put a code to a color, okay, if Josh were to describe a color and Matt were to describe a color, you should get the same code, assuming you can objectively see color similarly. Okay, so the code, the color code, provides an objective label for the color. So when you go to someone and tell them, I want my room to be macaroni and cheese yellow, who the hell knows what macaroni and cheese yellow looks like? Kraft macaroni and cheese is much yellower than Stouffer's macaroni and cheese, for example. But if you give them a Munsell code, okay, they can give you the exact color you want. And the Munsell color book gives you those codes. Okay? And the way it works is you take a little smudge of sediment. There's a little chart in here. You hold it on plastic and you compare the color and you give it a code to it. Okay? So that's how color works. And apparently every color in nature is describable using a Munsell code. But not all colors in nature are in this book. This book just has colors of earth and materials. So yeah, it's a blend of, we'll talk about chroma and all that crap on Monday. Okay? The second thing is grain size. All right? The soil is composed of sediments of different sizes. And soil scientists use something called a ternary diagram for describing. Just pass like one for every couple of people. I just have 5 copies. Soil is, geologists, sedimentologists are really anal about sediment grain size, and they are very precise in how they measure grain size and will quantify grain size. Soil scientists are a little more sort of aesthetic and artistic about it. What soil scientists do is they try to determine the relative concentrations of clay. Remember, this is clay size, not clay mineral. Clay on the top of the chart, silt on the lower right corner, and sand on the lower left corner. Clay is like baby poop. When you rub clay between your fingers, it's as smooth as baby poop.
I'm not sure.
Yeah.
You need to try that. Silt, when you rub it between your fingers, you can't see the grit, but you feel the grit. Okay? You can actually feel the grit in the sample. Okay? And then sand is large enough to see, so it's gritty, but the grit is visible. Okay? And there's a way of determining what percentage of clay, silt, and sand exists within a sample. And depending upon what percentage, gives you a textural size. So the way this works is, it's like a 3-axis graph. Okay, anything that plots down here has no clay. As you move up to the apex, you have more and more clay. If something plots up here, it's pure baby poop. It's all clay. Okay? This axis is 0% sand. As you move down to the lower left corner, you go to 100% sand. Okay? Similarly, this is 0% silt, and this is 100% silt in the lower right. All right? Now you can do this in a quantifiable way, but you can also play with the baby poop and using something called the texture by touch method, determine whether you're dealing with a sand, a loamy sand, a clay, a silty clay. You can determine what field you are in on that diagram using this chart. Again, there's 5, so share. So we'll actually, it's a way of actually assessing where you're sitting on this turning diagram just by playing with your sediment. And I realized I have drinking water. We have water. We need a little bit of water to do that. Okay?
You don't have to taste the baby poop.
No, you don't have to. But sometimes tasting the baby poop is helpful because sometimes you feel the grit in your mouth over your fingers. But the texture by touch method doesn't require any oral activity.
That's how you tell if it's a real pearl or not.
What's that?
That's how you tell if pearls are real.
Is that right? You rub it against your teeth?
Yeah.
And if is that true? I always thought that was
Yeah,
a fallacy.
yeah. I saw it on a Pearl show on,
Okay,
on
that's
Discovery.
got to be true.
The divers were saying.
All right, so there's color, there's texture, there are also structures. Sometimes the soil clumps to form things we call PEDs, P-E-D-S, and there's a variety of different PED types. To get PEDs, you need to have a soil that's rich in clay. The clay serves, just like the kitty litter story, the clay size material sort of causes the sediment to clump in certain ways as it's wetted and dried, and the clumping, the type of clumping you get, is a product of how the water table is moving and how much meteoric water is moving through the soil. We have very clay poor soils, so we're not likely to see many different types of PEDs, but we'll look when we do this. Another good indicator is the mineralogical content. Is your sand or silt composed of quartz? Is it rock fragments? Is it feldspars? Is it something else? We also commonly have in our soils in certain horizons calcium carbonate. Okay? It turns out that, are you familiar with periphyton?
Yeah.
Okay, periphyton is sort of a microbial mat that forms on wetlands, particularly prairies where there's no canopy. So there's enough light coming in to this prairie floor to allow microbes to grow, and then when the prairie dries out, those microbes die, and that mat, that microbial mat, disintegrates, lays on the bottom. I'll look for pieces of old mat from last wet season. And those microbes actually produce calcium carbonate. Okay? So one good indicator of a prairie soil is that you've got calcium carbonate in one or more of the horizons. And you test for that using HCl, hydrochloric acid. A little drop of 10% HCl, if it fizzes, there's calcium carbonate there. So, all right? So those are the, and then there's all kinds of other sort of features. Do you see roots? Do you see modeling? Are there differences in color? Or is the color uniform? And so on. Okay?
So heads are like lumps?
Heads are lumps, but they're lumps of different shapes. Like what we may see granular peds, and they look like small marbles. In different areas, you might get blocky peds or platy peds. Places where the soils are more interesting. So, all right. So that's a soil description lesson in a nutshell. The other handout I have here, which I'll give to people in class on Monday and upload onto Angel, is sort of a formal protocol for describing soils, what you have to do. So there's a regular method to follow. And I always find when you're doing this for the first time or the first few times, it's good to follow that protocol so that you remember to do everything you're supposed to do. So when it's over, you have all the data. And then usually when you take out a profile and you've got the horizons described, you're going to take some back, sample each horizon in a sample bag of some kind, and then there are other tests you can do back in the lab. So we might do that today.